All right, let's get right into it. We're going to pull back the curtain on one of the most critical yet kind of invisible algorithms that literally holds our digital world together. It's called consistent hashing, and it is the absolute secret sauce behind pretty much every service you use every single day.
So, have you ever actually stopped to think about this? I mean, we hear about servers crashing all the time, right? Yet, for the most part, our favorite apps, our games, our websites, they just keep on chugging along. How is that even possible? Well, it's not magic, I can tell you that. It's just some really, really brilliant engineering designed to solve a massive problem.
So, to really get why the solution is so clever, we first have to look at the most basic, most obvious approach. Okay, so imagine you've got a ton of data and you've got a bunch of servers. The first thing you'd probably think to do is distribute all that data using a simple math formula. And here it is. It's called the modulo hash. Now, it sounds a little intimidating, but it's really not. You just take a piece of data, we call its unique ID the key, and you run it through a function to get a number. Then, you use that little percent sign, the modulo operator, to get the remainder after you divide by n, which is just your total number of servers. That final number tells you exactly which server the data should live on. Seems easy enough, right? And you know what? In a perfect world, this works great. Just look at this table. We've got our 4 servers, and the formula has just neatly spread out all our data keys across them. See? Key 1 goes to server 0, keys 2 and 3 land on server 1, and so on. Everything has its place, it's balanced, it's predictable. But as we all know, the internet is, well, it's almost never a perfect world. So what happens when things go wrong? Let's say one of our servers, maybe server 1, just blinks out of existence. It goes offline. Suddenly our nice, stable system isn't so stable anymore. Now, this is where things get really, really bad. Check out this domino effect. Our number of servers, n, just changed from 4 to 3. That means we have to recalculate everything using hash of key modulo 3. And would you look at the result? It's absolute chaos. Almost every single key gets remapped to a totally different server. It's not just the data from the server that failed. It's pretty much everything. This massive reshuffling, it actually has a name. It's called a storm of cache misses. And all that really means is the system is frantically looking for data where it thinks it should be, but it's not there anymore. This can totally overwhelm the remaining servers and bring the entire service grinding to a halt. This is the exact problem that desperately needed a better solution. And enter the hero of our story, consistent hashing. The whole genius idea is right here in the definition. When the number of servers changes, it's designed so that only a tiny, tiny fraction of the keys need to be moved around. It promises minimal disruption instead of total chaos. So how on earth does it pull this off? Well, it all starts with this really clever mental model, a hash ring. So first, just picture a giant number line. I mean, a truly massive one that represents all the possible outputs from a hash function. Then, and this is the aha moment, you bend that line and connect the two ends, forming a continuous circle, a ring. And finally, you use that very same hash function to place each of your servers at a specific point on that ring. Now, here's the really elegant part. To find where any piece of data belongs, you hash its key, which puts it at its own spot on the ring. Then you just travel clockwise around the ring until you hit the very first server you see. And boom, that server is its home. It's a super simple, predictable rule. And this is why the ring is so brilliant at handling change. I mean, this slide says it all. If a server gets removed, its data doesn't just scatter everywhere. Nope, it just gets handed off to the very next server on the ring. The impact is totally contained. And what if you add a new server? Well, it just neatly takes over the keys that fall right before it. The disruption is localized, it's minimal, it's manageable. But, nothing's ever that perfect, right? This basic ring idea has a couple of potential issues in the real world. First, servers might not be spaced out evenly, so if one disappears, its neighbor could suddenly get slammed with double the work. And second, just by pure random chance, all your data keys could clump together in one spot, overloading one poor server while the others just sit around doing nothing. The solution to both of these problems is this incredibly smart technique called virtual nodes. So instead of placing each physical server on the ring just once, you pretend that each server is actually hundreds of smaller virtual servers, and then you just scatter them all over the ring.
And this slide right here shows you exactly why that's so effective. On the left, without virtual nodes, you get these huge, clunky, uneven chunks of responsibility. But look at the right. By representing each server many times, you break up the ring into all these tiny, much more evenly distributed slices. It just automatically smooths out the data distribution and the server load. It's genius.
So, how many of these virtual nodes do you actually need? Well, the research shows that the magic number is somewhere around 200 virtual nodes for each physical server. If you do that, the difference in the amount of data between your busiest server and your quietest server drops to a totally manageable 5%. It's just a really powerful way to get balance. So let's just quickly recap the big wins here. You get minimal data movement when you add or remove servers, which makes it incredibly easy to scale your system up or down. Your data is spread out way more evenly, and it helps solve that nasty hotspot problem, so you don't have all the data for, say, a viral celebrity photo overwhelming a single poor machine. So at this point, you're probably thinking, okay, this sounds great in theory, but is anyone actually using this stuff in the real world? Oh yeah, the answer is a massive, resounding yes.
Consistent hashing is literally the backbone for some of the biggest systems on the entire planet. We're talking databases like Amazon's DynamoDB and Apache Cassandra that power countless apps, the chat servers at Discord, content delivery networks like Akamai that bring you videos and images in a flash. It is everywhere, silently making the internet a whole lot more resilient for all of us.
So the next time your favorite app works flawlessly, even when you hear there's a big outage somewhere, you'll know one of the little secrets behind that stability. And it kind of leaves you with a question to think about, right? What other incredible, invisible algorithms are out there, just quietly making our digital lives possible?